welcome to the first class of mathematics optional altogether, we can say, because actually the calculus is the one actually which forms the basis for many of the topics, not a single topic. Many of the topics actually are dependent on the calculus. So that's why actually you have to spend more time on calculus. So because actually this is one of the fundamental topic. So almost every topic depends on this calculus. So if you take it, so fluid dynamics, if you take it, again it is dependent on this calculus. If you take partial differential equations, it is dependent on calculus. If you take ordinary differential equations, it will depend on the calculus. If you take complex analysis, it is dependent on the calculus. So even 3D geometry also to some extent it is dependent on calculus. Numerical methods altogether is dependent on calculus. So any topic for that matter, if you take it, that is dependent on calculus, because this is the most fundamental topic and it will be very widely discussed at +2 standard. So that is the reason actually it has got utmost priority. So directly there is a huge amount of the marks weightage is given for the calculus topic of UPSC. At the same time, this calculus actually plays critical role even in the other topics as well. So that's why actually I strongly suggest spend more time on calculus. And that too, this is actually, so we can say that actually we cannot say this is an easy topic or we cannot say it is a tougher topic. So it can go either way. So sometimes actually paper can go very easily in the case of the calculus. Sometimes actually it can go very tougher in the case of the calculus, because the number of concepts what you are going to learn in case of calculus is going to be very, very wide. So every concept can be twisted or every concept can be given in an easier manner. So that's actually, if you take the previous years also, 2015-16 is actually very, very easy to solve. Almost all the questions you will be able to solve from the calculus. But in 2017, actually it is quite tough to solve. In 2018, it is a moderate. Then later, actually, it will be easier. So like this, actually, it can go in a wider way. So it can go deeper into tougher level or it can go very peripheral level. But understanding of calculus is a must from all the topics point of view. Got it? So first actually let us list down what is the syllabus that we are going to discuss as part of this calculus. And then actually depending upon that, actually we can see some of the weight. So weightage actually I will show year wise. At the same time actually I will show you some of the model questions, or actually the previous year questions, actually what is the standard that was asked, actually you can make out. So because actually this calculus is the one topic actually which you might be already familiar with most of the people. So at +2 standard also actually the questions can come in. So that is why actually you will find the familiarity of almost all the questions, but actually we need to go a little bit deeper into that. Got it? So let me list down the syllabus first. Okay. Calculus. So real numbers. Functions of real variables. Functions of real variables. Limits, continuity, differentiability. Limits, continuity, differentiability, mean value theorem, mean value theorem, Taylor's theorem with reminders, indeterminate forms, indeterminate forms, maxima and minima, asymptotes, asymptotes, curve tracing, functions of 2 or 3 variables, in that actually limits continuity partial derivatives, limits continuity partial derivatives maxima and minima, Lagrange's method of multipliers, Lagrange's method of multipliers, Jacobian, and then Riemann definition of definite integrals, indefinite integrals, infinite and improper integrals, infinite and improper integrals, double and triple integrals, double and triple integrals. So this is only evaluation techniques. So surface area, volume integrals. So this is the entire syllabus actually what we are going to discuss as part of this calculus. Right? So this is the total syllabus broadly what we are going to discuss. Now, before proceeding further, I just wanted to let you know. So I wanted you to know that actually you asked me some of the questions. At least actually I will be able to answer that, and then actually I will proceed further into this. So what is the expected information you are looking for as far as this particular topic is concerned? What are all the information you are looking for? You give me some questions, I will answer all those questions, and then I will proceed further. Okay, so you people are expecting from basic level from the limits. Okay, polar curve tracing. How many classes can we expect? Books, weightage. So I'll summarize the questions. Limits, basic levels should be start. And then actually polar curve tracing. The third one, books to refer. Fourth one, how many classes? Approximately. Weightage. Class discussion sufficient or not? right? So broadly, these are all the questions actually, right? Okay. So NCERT books needs to be referred? No, you don't need to refer NCERT books at all, because actually we operate above the NCERT level, but I will be covering from the basics. So whatever the basics I cover, actually that is mostly from the NCERT books or a little higher than that. So that is sufficient enough. So you don't need to look back for the NCERT books at all. And then actually, so I'll be starting from the basics. So don't worry about it. So I will start from the limits and the continuity and differentiability, and then actually we can proceed further on that. So this actually I will take it. So when we start with the classes, and then actually polar curve tracing. So polar curve tracing, actually I will explain how to trace the polar curve. So as part of the curve tracing, but keep it in mind that actually, so return on investment on curve tracing is less. So once we go through the previous year questions, actually we will get to know that. So none of the questions were asked from this particular sections, though actually this concept is a little bit tougher or trickier. So it depends on actually problem to problem, completely drastically varies. But I will give you an elaborate idea how to trace the polar curve and how to manipulate it. Got it? And then actually books to refer. So don't go more books, only 2 books I suggest. You stick it to only 2 books, and the models from those 2 books actually are sufficient enough, which covers almost every model. So there is one book is actually, so BS Gravel I follow. BS Gravel actually, this covers actually the integration cycle to a greater extent. Integration and applications. This is very good book. But coming to the differential part, so differential calculus, integral calculus, actually if you divide it, integral calculus, BS Gravel is actually pretty good book. But for the differential calculus actually, so differential calculus, Krishna series. And don't go beyond these books. So this is more than enough, which covers all the models, right? Just stick it to these books. Don't go multiple materials or actually multiple things. Actually, don't go with that. But actually, we have covered mostly whatever is required from the UPSC point of view in our Indian Civils material itself. And the material actually, so content is extracted from these 2 books. Those content also actually more or less it is sufficient. If you have still time, you can practice more number of models within these books itself. Got it? And then actually, how many classes approximately it will take? So this is being actually involving multiple concepts. So it takes actually minimum of 30 classes. Minimum 30. So classes actually around 30 classes I will take it for this particular topic. So I think within 1 to 1.5 months actually it will be completed. So maximum actually it will go 30 classes. And then actually weightage actually it varies. So year by year actually it is varying. So the highest actually I noticed that actually 95 marks only for this particular topic. And the least I noticed that 60 marks is the least. In 1 year actually it was the 60 is the least and the highest is the 95. And that actually I will discuss clearly. And then actually class discussions are sufficient. So I will be covering all the models. So whatever is expected from the examination actually that models actually I will be covering in the classes itself. But it is always advantageous if you practice more number of models from the textbooks. So that I strongly recommend. So I will be covering all the models, but actually covering model means actually I will be solving 1 or 2 problems. But if you solve 10 problems, then you will get comment on that. So that's why actually class discussion will be covering all the models, and at least actually 2 questions for each model actually I will be covering minimum. But actually it will be good if you practice more. So that's why actually you stick it to the class notes and the practice from the books also, right? So I think I have covered all the aspects. Got it? Now let us see. So I'll just show you. See this, the weightage actually, if you notice in this particular one, right? So this is actually 2019 paper. And in that actually I have separated questions. So linear algebra, calculus, analytic geometry, ordinary differential equations, dynamics and statics, and vector analysis. So these are all the topics actually as part of the paper 1. So I'll just enlarge this. Okay. See this. So in this actually in 2019, calculus was given a weightage of 70 marks. So 2019 it was given a weightage of 70 marks. And then actually, so here see this 2018 actually calculus was given a weightage of 95 marks. See the weightage. So which is I think so 95, and dynamics and statics actually it is 106 marks. And if you notice the trend, right? So 106 is the weightage here. And here actually, so this is dynamics and statics 70 marks. In the calculus also it is 70 marks here. And see this 2017 paper. So calculus was given a weightage of 60 marks, and dynamics and statics also is 60 marks, and 87 is for ordinary differential equation. So here actually more or less equally distributed for each and every topic. So not a drastic difference, except for this topic, ordinary differential equations is 87, and the so vector calculus is for 53. But the calculus actually it was given 60 marks weightage, which is the least among all the previous 5 years. And see this here actually, this is 2016 paper. In 2016 it was given for the 75 marks calculus, and here also more or less actually equally distributed. But if you notice, in all the years actually this vector calculus was given a lesser priority. So this actually you can keep it in mind. And then actually, so this is 2015 paper. If you notice here actually 93 marks is the weightage for the calculus, and rest of the topics actually it was given lesser weightage. And dynamics and statics actually if you notice every year actually more or less actually it plays higher role. So just a minute. Yeah, so Vishal is on. Okay, fine, right? So this was given for 84 marks, and this if you notice calculus is the highest weightage in this particular year. So there is 2015 paper. So among all the years, if you notice, the calculus actually it was varying from minimum of 60 marks to maximum of 95 marks. So which is actually almost higher, actually second priority you can say when compared to the statics and dynamics. So that actually we have to keep it in mind. And as I said earlier, here actually abstract algebra is the one actually which was given least priority in all the years. But the effort that you are going to put on abstract algebra is very, very high. But the priority actually from the UPSC point of view is actually very, very less. And if you notice what is happening is, so for the past few years actually, many of the people actually used to follow your trend that actually people feel that actually one is the statics and dynamics, and fluid dynamics and mechanics, and the real analysis. These are all the three topics actually many people actually will feel very, very tougher, and then actually they used to ignore, and then actually from the rest of the questions actually they used to take the questions. But nowadays actually UPSC realized that they have to give higher priority to these topics. So that's why actually mechanics and fluid dynamics, statics and dynamics, and the real analysis actually, so you cannot ignore it, and the questions are actually spread across. So each question, each topic is spread across multiple questions. So that's why actually they are giving higher priority. That means the strategy needs to be changed when compared to the previous years. The strategy is now, which were ignored earlier, which were felt tougher earlier, now you have to take high priority, and then actually you have to do it. There is no other way. So that you have to keep it in mind, right? And across years, I did notice that actually this abstract algebra, see this is 50 marks here. And here actually 60 marks actually. So 60 marks in 2016. And here if you see abstract algebra, it was given only for the 45 marks, and in 2017 and 2018 actually it was only for 35 marks, very, very less. And see this here actually it was for only 40 marks. Among all the 5 years, if you notice, except for 1 year actually none of the years actually it was crossing 50 marks. But see the calculus weightage. And if you see the statics and dynamics, so if you see the mechanics and fluid dynamics weightage, so 80 marks here. And see this, so this was the last, only 1 year actually it was given for the 50. And see this, here it is 60 marks, and here it is 70 marks, and here it is 65 marks. So like this actually, there are certain topics actually now they are taking priority which were not the earlier one. And also the priority is not only from giving weightage, the other way is actually they are spreading across multiple questions. So these two you have to keep it in mind. And calculus, nevertheless, very, very important topic. Not only the weightage point of view, even if you notice the weightage point of view, if you notice, it is given higher priority, 93, 75, 60, 95, and 70. See this? So most of the time 70, 2 times 95 for the past 5 years. Only 1 year actually it was 60. So that's why actually you have to give higher priority, not only from this topic point of view, even from the other topics point of view also. Ordinary differential equations, partial differential equations, complex analysis, mechanics and fluid dynamics, statics and dynamics. So every topic actually it plays crucial role. So that's why actually you give very, very high priority. So spending more time in calculus actually it will give you a better result. So that you have to keep it in mind. Got it? So this is about the weightage. And also if you notice, see this, so these are all the questions actually that was taken from the previous years. So these questions, if you notice, so this is in 2015. See this particular question, it was from the limits, or actually indeterminate forms, you can say. It can be converted into indeterminate forms. So that means actually the questions are asked from the limits, that is one section, and another is actually it was asked from the integrals. So this is actually very, very basic level of question. This is a +2 standard question. Actually it was given straight away like this. So which is the fundamental theorem of integration. Actually with that we will be able to solve it easily. And then actually this is a conical tent is of given capacity. For the least amount of canvas required for it, find the ratio of its height to the radius of its base. So this actually from the maxima and minimum concept. So maxima and minima actually more or less it is an application level of question of the maxima and minima. So one question is from the limits, one question is from the integration, and one question is from the maxima and minima. And then actually see this. So here actually again evaluate the integral. So this is a double integral and this is a double integral, and this is actually for the function examine the continuity and differentiability. One question is mandatorily from the continuity and differentiability every year. That too multivariable. So at least actually two variables will be there. So multivariable function continuity and differentiability is one topic actually many people will feel tougher. Why people feel tougher is the concept is easier and you will be able to understand it, but resources are less. That is the problem. So in those books actually whatever I have covered, right? So in that actually to some extent you can find it, but actually even those books also actually not to a greater extent actually this concept was covered. That's why actually the questions were asked from this particular question in this particular section. So that is multivariable continuity and differentiability. So this is one concept actually many people feel actually need more practice on that. Got it? And this one, see this. So this is again one question is from the integration. So and then actually finding the maxima and minima subjected to the conditions given by this. So this is the Lagrange's method of multipliers that you need to apply for this. And this is multivariable maxima and minima question. And this is also multivariable finding the continuity and differentiability. So this is also actually continuity and differentiability. And this is find the surface area of the plane. So and this is actually finding the surface area, which is an application of the multiple integrals. So application of multiple integrals to find out the surface area is one concept, which is a little bit tougher concept. So in that section actually it was asked. And then actually see this evaluate the double integral. So it was given a range, and with that actually subjected to this condition actually. So you need to identify the value of the integration, which is a double integration. So finding out the integration is a mandatory concept. Mostly the double integrals if you notice. And even the applications also actually it is mostly from the double integrals, and no questions actually till now we noticed from the triple integrals. So triple integrals it was given very lesser priority, because if you understand the double integral concept, then actually it is extension of the double integral itself. So that actually you have to clearly understand this, right? And in 2017, so this actually integrate the function within this particular range. So again, actually this is the integration, which is a double integral again. And then actually find the volume of the solid above the xy plane. So this is actually finding out the solid volume. So finding out volume actually you can do with the help of the double integral, and you can even do with the help of the triple integral. Again, this is an application of the double integrals, you can say. And then actually this is again, see this calculate the dou square f by dou x dou y and dou square f by dou y dou x at 0, 0. So this is again multivariable differentiability test. So this is again differentiability. And then actually examine the improper integral. So this is an improper integral actually you need to characterize this particular integral value. So this is actually mostly covered from the real analysis point of view. It's not from actually the calculus. And then actually this integral. So this is again actually the integral. So this is again the real analysis concept. And this is, see this, determine limit z tends to 1 and 1 minus z tan pi z by 2. So exist or not. So finding out the limit. So limits is one important concept. And this is also actually finding out the limit. And this, see this, find the shortest distance from the point. And this is also maxima and minima concept. And this ellipse revolves about the x-axis, find the volume of the solid found by this. So this is again actually application of the double integrals. And find the shortest distance between these lines. So this is also finding the maximum and minimum value. And this is determine the which of dou f by dou x at 0, 1 and dou f by dou y at 0, 1 exists and which does not exist. Again, this is multivariable. As I said earlier, if you notice, every year the questions are asked from multivariable differentiability and continuity test. So every year there is a question because there is a lack of resources there. So that is the important thing. But the concept is easier, lack of resources. So you need to practice more on this particular section. That is a mandatory concept. And improper, so and limits also actually indeterminate forms actually you need to practice, and double integrals. So these three sections, if you notice, every year actually the questions were asked, and the maxima and minima. So that too, few times actually it was asked straight away maxima and minima of one variable, and actually many of the times if you notice applications. So applications of finding out the maxima and minima actually it was focused. So applications actually you need to practice more, and the applications actually, especially from the engineering mathematics, actually you will find more applications always. So rather than the theoretical mathematics, actually engineering mathematics will be having more number of application related problems. So that's why actually BS Gravel is one book for at least for the integral calculus. So most of the concepts whatever we are covering here, it is from the BS Gravel. It covers almost every model in this, right? And then actually finding the maxima and minima again and evaluate the integral. So this is a double integral. So in 2019, actually, if you notice, so this is a continuous function, and then it will find the value of f of pi by 2. So again, actually finding the continuity and differentiability here. So this is also a continuity. See, f of x is equal to mod cos x plus mod sin x, and differentiability test again. So this is also finding the differentiability, and find the maximum and minimum values of the function f of x is equal to so and so. And this is actually single variable maxima and minima at one particular value. And this is u is equal to sine inverse. Then actually, so whether it is a homogeneous function of x comma y. So this actually finding out the partial derivatives. There is one concept that partial derivatives evaluation actually this particular problem falls into. And then actually using the Jacobian method show that f dash of x is equal to 1 by 1 plus x square, and f of 0 is equal to 0. Then f of x plus f of y is equal. So this is actually, so real analysis point of view, actually this will be covered. Got it? So like this actually, if you notice all the questions whatever we are seeing here for the past 5 years, mostly the questions, one is the application level of the questions, and another is the limits actually. So more variety of the limits will be there. So that limits actually it was focused, and another is actually improper integrals. To some extent it was focused, and so finding the maxima and minima almost every year it is there. Finding the maxima and minima, and the two applications of maxima and minima, and so multivariable calculus every year it is there. So maxima and minima multivariables are the must understanding concepts, and double integrals is the one actually which plays very crucial role not only in finding the integral, even for applying that to find out the volumes or to find out the surface areas actually is one more important concept actually which you need to be very clear about. To summarize, these are all the three areas actually you need to focus for the entire marks weightage that was given for this particular topic. Got it? Any questions on this? Any questions? Fine. Okay. Now let us see what is the syllabus actually it was listed. Now see this actually. See this. So real number. So it starts with the real number system, and then actually real number actually we have to represent the real number with a variable, and that variable actually. So then actually we start discussing about the real variable functions. So functions is the fundamental concept for the entire mathematics we can say, and that fundamental concept starts with the calculus. So we need to understand what is a function, and we need to understand what is a real number, and then actually once you identify the real number, so started with the real number, just a number representation with a variable actually relation between two different variables which we call as the function. And again when there is a relation between two different variables, then actually that relation, whether it is a continuous relation or a discontinuous relation, or actually when a limit approaches or not, actually everything actually needs to be understood clearly. Hence actually we started analyzing the function. So started with number representation with variable actually related with other variables with a function, and we are characterizing the function. So the characterizing the function, actually we have the characteristics like identifying the limit and continuity of that particular function and the differentiability of that particular function. So these are actually some of the very, very basic level of mathematical understanding that are associated with while defining the function level itself. So because most of the other topics actually we assume that the function was defined and it is a proper function, and there actually we start analyzing it. But calculus and the real analysis are the ones which starts finding out the characteristics of the function and defining the function itself. So the definition of the function level actually, which is the most fundamental aspect actually, which we are going to deeply discuss in the case of the calculus and the real analysis. So the differentiability is actually one more characteristic. And then actually mean value theorems. So mean value theorems are actually, which is by common sense actually we can make out the mean value theorems. That is, supposedly if I give you a simple example, that actually suppose if there is actually some kind of raise like this, then actually at one place actually you notice that actually this is keep on raising. At another place actually you notice actually it is keep on falling down. Then actually you can be sure that actually at somewhere actually it has taken turn. Otherwise actually it wouldn't be falling down, right? So this fundamental understanding which we call as the mean value theorem. So by common sense we can make out what is this mean value theorem. But this mean value theorem understanding gives a lot of flexibility, or actually a lot of unsolved problems were solved based on this understanding, especially identifying the functions of so identifying a complex function into a polynomial format with the help of the Taylor's expansion or the Maclaurin's expansion. For all such kind of expansions actually this mean value theorem actually which forms the basis. So hence actually you need to understand what is this mean value theorem, and then actually the extension of mean value theorem actually it comes with the Taylor's expansion. And again the Taylor's expansion further actually if you boil, so if you again analyze it, and one particular case of the Taylor's expansion which we call as the Maclaurin's expansion, and that actually is the one actually which has more number of applications. And then actually so indeterminate forms. So indeterminate forms actually sometimes actually we notice in mathematics there is something called 0 by 0 format, or actually infinite by infinite format, or 0 into infinite, which we cannot give a proper conclusion for that. Now, so in such cases actually, so mathematics actually is the one actually which will be defining clear-cutly what is right and what is wrong. But this is the one place actually where if you multiply 0 with infinite, will it come as infinite or it will come as 0? That we don't know. That particular form which we call as the indeterminate form. Or actually if you divide 0 by 0, will it be 1 or actually something else which we don't know? Again infinite by infinite actually which we don't know, again like this. So for all such kind of things actually there are certain cases, even though it seems to be infinite by infinite format or 0 by 0 format which we call as an indeterminate format, but by giving appropriate values to that, we can at least make out what should be the appropriate value that may be an indeterminate format or that may not be at one particular value. So such values actually we will try to identify whether it is really an indeterminate format or actually at least we can find out a value for that particular function at one particular value. So that kind of concept actually we will discuss a little bit deeper into it. So that's what we call as the indeterminate format. And maxima and minima, so we know that actually in entire engineering actually almost every topic actually the application of this maxima and minima is there. So because actually this is very widely discussed concept because it is targeting the optimizing the values. So optimizing the cost, optimizing the area. So everything is actually related to finding out the maxima and minima from the mathematics point of view. So this concept actually we will discuss a little bit deeper into it. So this is actually at +2 standard itself actually it was initially introduced, but down the line actually it was so expanded to multiple conditions. So if I give you a straightforward function y is equal to f of x, then for that actually if I ask you to find out the maximum and minimum value at +2 standard actually you might have found very, very easily. But actually if there are multiple variables, then actually how can we find it out? That will be a complicated question. So but actually practically the questions were like that only. Not only from the UPSC point of view, even from the practical problems, engineering problems also actually you will find that when there is a multivariable function, for that actually how to find out the maxima and minima. So as it is very, very tougher to find out, at least our analysis was discussed only to two variables. So z is equal to f of x comma y. Till this extent only actually we were finding out. We are not involving more number of variables because the complexity goes very, very high. Even this level also the complexity is a little bit tougher. So this actually we have it in our syllabus and the questions were asked from only for this particular section, not from this particular level. So this actually needs to be understood clearly. And especially there is one popular method actually which was introduced, that is Lagrange's method of multipliers. So that is actually as part of multivariable calculus it was there, Lagrange's method of multipliers. And this is also one of the very, very important topic from the UPSC point of view, because if you notice, the questions were asked from this particular section to find out the maximum and minimum. The advantage of this is when there are certain constraints. So with the help of the constraints, finding out the maximum value. So without the constraints, actually it is okay. But if there are constraints, then that constraints actually will reduce the complexity to some extent. But with the help of the normal approach in this particular method, identifying the constraints and then actually involving the constraints to find out the maximum and minimum value, actually you will find it a little bit tougher. But you will be able to solve it, but the complexity is more. But the complexity was reduced to a greater extent with the help of the Lagrange's method of multipliers. But essentially, it serves the same purpose of finding out the maximum and minimum value. So this actually, it was discussed to a greater extent. And so this actually, you can expect the questions. Definitely, it comes from that particular section. And then actually, so functions of multivariables. So, and as I said earlier, see this particular portion actually, if you notice, except for this limits and continuity. So rest of the things actually are only the basics to understand this particular section. See this, so real variables and functions, limits, continuity, differentiability, mean value theorems, Taylor's expansion, indeterminate forms, all these things like maximum and minimum of single variable. And all these things, if you notice, everything is actually only the basis or actually basics that you need to learn to understand this particular section. But if you notice, the questions that are going to be asked only from this particular section. So UPSC philosophy is very clear. The philosophy is actually, they don't ask any questions from the basics. They will ask questions from the advanced level. So by asking the questions from the advanced level, they will be able to cover all the basics in that particular one. So that means if you are able to solve advanced level question, they can be sure that actually you know all the basics of that. So that's why the questions were asked only from the advanced sections, not from the basic section. That you have to keep it in mind. Not only for this topic, even for all the topics, it is exactly the same. Got it? So that's why actually, so try to target whichever is the advanced one, so that actually all the basics are covered in that particular part. So that's the reason actually this maximum and minimum, actually no questions you can expect. But Lagrange's method of multipliers and multivariable, finding out the maximum and minimum, actually you can expect definitely the questions that you have noticed from the previous year problems I have explained. And even see this, finding out the differentiability, continuity, or actually limits of a single variable is very, very easy. So even actually +2 standard also actually they can do, but that was part of our syllabus. But no questions you can expect from this particular section. The questions you can expect only from the functions of 2 or 3 variables. Again, the same concept. Limits is there, continuity is there, partial derivatives is there, maximum and minimum is there. See this, all the questions, if you notice, I have shown all the previous year problems, but only from these sections. See this, none of the questions you can expect from the top, except for only one section, that is actually indeterminate forms. So rest of the questions are only this particular portion. And then actually Jacobian, none of the times actually it was asked, and you can ignore that. Riemann definition of the definite integrals. And this is actually as part of real analysis that is going to be covered. I am not going to cover as part of calculus here. So this actually, it will be covered as part of the real analysis because this is more applicable there. And indefinite and improper integrals. So even improper integrals also is part of the real analysis. And then actually this one, double and triple integrals. So this actually I will cover to a greater extent. Deeper level I will cover, each and every concept I will clear. And then actually surface area calculation and the area calculation and the volume calculation. And these are actually most of the questions that were asked from this particular section. Especially most of the times, if you notice the integrals that were asked, the integrals are double integrals mostly, and the application of the double integrals. That is the last line which was there. And in this actually you can expect more number of questions. So that actually I will anyway cover to a greater extent. Got it? So this is grossly what we are going to discuss as part of this particular topic. Got it? So any questions? Any questions you can ask me now. Fine. Okay, fine. So with this actually, I would like to stop the class for today. So we actually start the classes from tomorrow onwards. So I'll straight away go into the topic. I'll start with the fundamentals. Got it?